Welcome to this video, and today we are going to be explaining first powers, zero powers, and negative powers or exponents. Um, and the reason why I'm doing this is because although you probably won't see this necessarily in a high school classroom and almost definitely not a middle school classroom, um, I find this helpful to explain how these things work. It's a common area of confusion. Okay, what is if I take something out of the first power, what is that? Okay, what about a zero power? What about a negative power or exponent? Um, and again, it helps me. Hopefully, you find it helpful as well. And so I'm going to start over here on the right side of the page because most people, that I run into, as long as they know what exponents are, they are very comfortable with positive powers. So let's take 10 to the third, and I'm going to start by expanding it. So 10 times 10 times 10, because that's what exponents are. It's repeated multiplication. If there's three of them, I'm going to have three of them multiplied together. And what is that? 10 times 10 times 10. Well, that is 1,000. Easy enough, right? And then gonna just switch to a different color. Let's do 10 to the 2. And again, two copies of 10 being multiplied to each other. 10 times 10. What is the result? It is 100. Um, you might be saying, okay, great guy, this is nothing profound. And so this is kind of where the trick of this illustration comes in is, okay, what is the difference between, looking at 1,000 and 100? What do we have to do to get between those two numbers? Well, we end up doing what? We end up dividing by 10, right? 1,000 divided by 10 will get me to 100. Um, and I mean, if you expanded this out, if you put over here 10 to the fourth and, got the result 10,000, you would find that 10,000 divided by 10 will get us to 100. And you could expand it out as far as you wanted to the right with as many powers. The result would be the same. We are always going to be dividing by 10. Um, and so if we do that, okay, 100 divided by 10. And again, this, for some people, taking something to the first power is a little bit confusing. Like, what is that? Well, if we just keep on following this pattern in our table, okay, from 1,000 to get to 100, we divide it by 10. Okay, what's 100 divided by 10? Well, again, calculator if you need it, right? But 100 divided by 10 is 10. All right. And so, going up to where, just to show the expansions here, 10 to the 1, well, it's just one copy of 10, right? Here, again, just looking at kind of the pattern that's starting to form in this table, we have three copies of 10 for 10 to the third. We have two copies of 10 for 10 to the second. We have one copy of 10 for 10 to the 1. That makes sense, all right? 10 to the 1 is 10. It's one copy of 10. And okay, again, tricky one for some people is 10 to the 0. What does a zero exponent do? Well, we can explain that or show that, illustrate how this works by just keep on going in our table where we've been dividing by 10. So 10 divided by 10 is what? Well, it's 1, right? And you might be saying, okay, this is 10 to the 0, guys. So I have 0 copies of 10 here. Like, for now, let's just leave a question mark. Maybe we're not quite comfortable saying what that is. But we can say, okay, following, this bottom part of the chart here, we've been dividing by 10 this whole time. It's 1. It has to be. And then let's keep on going, and we'll go and fill in that expansion little slot in just a second there. But to get from 10 to the 0, and okay, we have 1, right? We're dividing that by 10. Well, that means 10 to the negative 1 is going to be 1/10. 1 divided by 10, right? We could make that into a decimal. I like to have it the fraction here, and you'll see why. So 1/10, right? Okay, how do we get 10 to the negative 2? Well, again, keep on keeping on here. If it ain't broke, don't fix it. We divide by 10 again. What do we end up getting? Well, again, fractions are kind of tricky for people, but if you need to, and I'll show it here, 1/10 divided by 10. You could throw this into a calculator that has a fraction function and get it just fine too. But we know that, okay, especially when we're working with fractions, it's helpful to instead multiply by the reciprocal. So what's the reciprocal of 10? Well, it's 1/10, right? So 1/10 times 1/10, well, that is 1/100th. 1/100th. Put it up here next to all the other ones. And okay, we're clever people, right? And I'll get, a little highlighter just to kind of show this on the page. All right, over here with 10 to the 2, right? That ended up being 100. Well, let's go look at 10 to the negative 2 and see if there's any similarities, right? Well, 10 to the negative 2 is 1 over 100. So 100 and 1 over 100. There's kind of a little pattern there arising, right? Um, and so, well, again, looking at my little table here, I'm gonna get a blue highlighter. Okay, 10 to the second was 10 times 10. Well, 10 to the, whoops, 10 to the negative 2 is gonna be 1 over 10 times 10. And I mean, again, there's not a little trick here. We're just, seeing patterns arise out of this little illustration here is, okay, 1 over 100, you know that 100 is 10 times 10, all right? 1 over 10 times 10. And again, let's keep on keeping on here. Keep dividing by 10 to get the last one, our 10 to the negative third, right? Well, it's going to be, again, use a calculator or another method if you need to, but 1 over 100 divided by 10 is going to be 1 over 1,000. And what's 1 over 1,000 if we expanded it as 10 powers like we've been doing in this table? Well, it's 10 times 10 times 10. It's 3 copies. Again, just to show again, kind of re-emphasize these things. 10 to the third over here was 3 copies of 10, and 1,000, well, 10 to the negative third was 3 copies of 10 in the denominator in this case, but it's, we still see 3 copies of 10, and the result was 1 over 1,000 instead of just normal 1,000. So what can we conclude by looking at this table? Well, we can conclude this, right? That negative exponents are just flipped over, right? We end up having the same amount of copies as we had with the positive, kind of counterpart, 3 versus negative 3. We have 3 copies of 10 being multiplied, but in the denominator. And, the result being what it is, 1 over 1,000 versus 1,000. And so to kind of fill in the rest of my table, because we purposefully skipped 10 to the 0, right? Because we just maybe weren't quite sure what was supposed to be there. But 10 to the 0, we could just say is 1, and then, 10 to the negative 1 is 1 over 10. And then, we keep on going on. We end up getting more and more copies of 10 as we go further and further along. And so, maybe should have talked about this at the beginning of the video, but why did I pick 10 of all things? Well, for most people anyway, it's pretty easy to think about and divide by and work with multiples of 10. We could have put any number here, though. You could have put a 2, a 5, a negative number, whatever. This pattern is going to fulfill no matter what, including with x, because, okay, what is, x or a different variable? Well, it's just a number, right? It's just a number that, we're not necessarily defining. And so it follows for that also. So no matter what, regardless of what number you put here, 10 to the 0 will always be 1. Negative exponents are always, always, always going to flip into the denominator every single time. The same amount of power, as its positive, kind of counterpart or pair would be, but it's just in the denominator instead of in the numerator, or, kind of a normal number, or, however you want to think about that, right? So anyway, I hope this video was helpful to you. If it was, feel free to like it. If you like this kind of content, please subscribe. And if there's anything that you would like to learn about, let me know that in the comments as well. I'd love to, illustrate or, kind of explain some things that you've been thinking about. But thanks for watching this video. Take care, everybody.